It's time for a bit of a showdown. We've got 5 Apple Silicon Macs, M1, M1 Pro and M1 Max models, and we're going to be testing them against each other in a video rendering showdown.
We've got Blackmagic 4K, 6K and 12K footage, the latest version of DaVinci Resolve, and a whole day to test them.
And to represent the x86 side of computing, we've got a notebook PC, a full-on workstation, and 2 Intel Macs. I think this is going to be interesting. So we spent the whole day testing all of these machines yesterday, and today we're running through all of the numbers and trying to make sense of it all. And rather than script this particular video, we've got some notes here which we'll be referring to as we go through the video. We've got all of the results, and we're going to try and distill them into some useful opinions for you guys.
Yeah, but before we start, there's some really important things to bear in mind about all these tests, so don't skip this bit.
Yeah, we don't want anybody to miss the point here. The test is all about seeing how the Apple Silicon machines compare to each other and trying to get a sense of their place in computing. We're so used to the x86 computing paradigm. So the x86 machines, the Intel Macs and the PCs are there just for context, really. This is not about Apple Silicon versus x86, and it's not about Mac versus Windows. It's a focused video test with a very specific set of codecs.
Absolutely. And it's also important to say that video timelines vary massively, so you can't take the figures here in isolation.
And of course, we're using Blackmagic RAW. And BRAW is a very optimized RAW codec. So just because a machine can edit 4K BRAW doesn't mean that it will be able to edit 4K Red RAW, for example. The codecs are different, and the Red codec especially is more demanding on the machine. So just bear all of those things in mind as we go through the test. So I think we need to introduce the 9 machines that we're going to be testing. So let's start with Apple Silicon, Pete.
So to begin, we have the M1 Mac Mini that we got last year. That has 8 CPU cores, 8 GPU cores, and 16 gigs of RAM. Moving on, we have the entry-level 14-inch MacBook Pro. That's got an M1 Pro chip in it with 8 CPU cores, 14 GPU cores, and 16 gigs of RAM. Moving up, we then have the 16-inch MacBook Pro, but this one has the M1 Pro with the 10 CPU core and 16 GPU core and 16 gigs of RAM again. Then we have a 14-inch MacBook Pro, but this is an M1 Max, so that's a 10 CPU core, and in this case it's the 24 GPU core model, and this has 32 gigs of RAM. And then the big daddy, the M1 Max, with the 10 CPU core, but this time the 32 GPU core, and a whopping 64 gig of RAM.
So representing basic Windows laptops, we've got the Razer Blade Stealth 13. This has got a quad-core i7, 16 gigs of RAM, and it also has a dedicated GPU, the NVIDIA 1650 Ti with 4 gigabytes of video RAM. Next, we've got this 16-inch Intel MacBook Pro. This is the 6-core i7, again 16 gigs of RAM, and a 5300M GPU with 4 gigs of video RAM. Here's our iMac, bit of a beast. 27-inch iMac with the Core i9 8-core CPU. It's got 40 gigabytes of RAM, and it has the Vega 48 GPU with 8 gigs of dedicated video RAM. And finally, representing Windows and x86 generally, is my workstation. This is a Lenovo P620 with a 32-core Threadripper Pro inside and 128 gigabytes of ECC RAM. For the graphics performance, we've got 2 Quadro RTX 5000 cards, each with 16 gigs of video RAM. Now, I do also, as you can see here, have the NVLink bridge installed. I've actually switched this off for all of these tests because recent versions of DaVinci Resolve seem to have introduced some bugs with that. When I tested it in the past, I found that enabling the NVLink bridge actually improved performance still, so that's worth noting.
So some of you might be wondering, why have we chosen these specific x86 machines? Well, part of that is because we have them, but also, you might be wondering, well, why are we using the GPU in the Razer? Because that's ancient, isn't it?
I've had people say this to me, the 1650 Ti, but it's not ancient. It was announced only in April 2020. So I know a lot of things have happened in the world since 2020, but it's not that old. And this is still a current machine. And if you go purely by the benchmarks on that, it actually seems to tie in with the performance of the entry-level M1 Pro.
Interesting.
So I think it's a fair comparison. And also it's the same price point. So around about £1,900 in the UK, and I think that makes it a fair comparison. Similar size, similar price. But what about including these previous generation Macs, Pete? Is that the right thing to do?
Yeah, I think it is, because all of these videos are designed to help people make purchasing decisions. And there's a lot of people out there with x86 machines that are well spec'd, and they're going to want to see if a move to Apple Silicon is of benefit to them. If we take a look at the 16-inch MacBook Pro, well, that's an entry-level model, so comparing it to the 16-inch MacBook Pro with Apple Silicon seems like a fair test. And the iMac, although it's a couple of years old and there's been newer CPUs and GPUs since then, it was a beast when we bought it and it was expensive, and it seems fair to include in this test.
Yeah, I'm interested to see how that iMac compares, particularly as we know it performs so well when we've done video testing previously.
Yeah, okay. So I guess the white elephant potentially in the room is that enormous workstation. Why have we included? Surely no one needs a workstation that big.
Perhaps not. And we're not suggesting for a moment that prospective purchasers of MacBook Pro notebooks should instead be considering an x86 desktop workstation, a PC workstation, or a Mac Pro workstation, whatever is your preference. Really, we've included this because this is the type of machine that typically a professional video editor working with professional codecs might choose to use. It's got a stronger CPU, in fact, than any Mac Pro that's been available, and it really shows what x86 is capable of. And I think those who are fans of Windows and x86, they'll be pleasantly surprised by what they see, I think.
Yeah, so we've got a good representation and spread of machines here to make this an insightful test.
Okay, so what we're going to do now is we'll just quickly run through some benchmarks of the machines before we get to the actual video test. This will help us to kind of get some context and see where they all perform. So we'll start by putting up the Geekbench 5 chart. And just remember, this is a synthetic benchmark that features a collection of different tasks, which are not necessarily representative of your real-world computing. Now, for single-core performance, all of the M1 chips here score pretty much the same, and they are the fastest chips here in our test.
The 1165 G7 in the Razer is very fast for single-core. Multi-core is more relevant, though, to today's testing.
And the 1165 G7 and the Intel MacBook Pro, interestingly, score the same for multi-core. This really shows, Pete, how Intel CPUs have moved on in the notebook market, because that quad-core is now performing at the same level as the 6-core i7 in the MacBook Pro. That's quite amazing. But as you'll see, the numbers in Geekbench don't always necessarily translate to the real world.
Yeah, we can't say this enough times. Don't look at Geekbench scores in isolation, ever.
Absolutely not. In our charts here, the iMac and the M1 Mini are very similar on performance for multi-threaded tasks. And then we've got the 8-core M1 Pro. Step it up again, the 10-core M1 Pro and Max chips are pretty amazing, hitting over 12,500 on their score.
And unsurprisingly, the 32-core 64-thread Threadripper Pro is way out in front.
It is, but of course, as we said, this is Geekbench. Let's take it with a pinch of salt and let's look at a real-world CPU benchmark test. Let's go to Cinebench. So this is the rendering engine for Cinema 4D. And here I think we see a more true representation of the performance. The Razer and the Intel MacBook Pro now have got quite a gap between them. Now, I think that's partly due to the better thermal performance in the 16-inch chassis. Since Cinebench is a more extended test, we run it for 10 minutes at a time.
Yeah, you'll notice too that the iMac comfortably outperforms the M1 Mini, and that's not a thermal thing. Cinebench is all about 3D rendering, and that's not an area of strength for the M1.
The iMac is actually outperforming the entry-level M1 Pro here as well. But the 10-core M1 chips put in a very good showing. You'll notice again, though, the margin of difference to the Threadripper is much larger here because, again, 3D rendering is not what M1s are optimized for.
So, shall we take a look at the Geekbench GPU scores?
No, I don't think so. Not after yesterday's excitement.
It was nonsense.
Pete here has got the 32-core M1 Max. I've got the 24-core M1 Max, and we were doing, actually, we're OpenCL testing, and this one was getting higher scores than that one in some of the tests. And we ran some tests on yours, and it was all over the place. And on mine, I've had scores between 42,000 and 58,000. So Geekbench's GPU test does not work for these machines.
No, it's nonsense, really. The test just never ramps up the GPU cores to their maximum capability. So what you're getting is just meaningless.
Yeah. So I think instead, let's get into our actual testing.
Yeah.
We're going to start with the B-RAW 4K footage. This is the Q5 codec. It's shot at 50 frames per second. Actually, this is a test scene that I shot, and I've featured it previously in other videos, but you will notice that the results are different this time, and that is because we're using the latest version of Resolve Studio 17.4.1. And just to clarify, Resolve Studio is the fully paid version that we're using for all of the machines in this test. Obviously, Apple Silicon version for the Apple Silicon machines, so everything is properly optimized. We've put that 4K footage into a 1080p timeline.
Yep.
Now, that's a fairly normal workflow because we're shooting in 4K right now, but we know we're going to be outputting to 1080p on YouTube. This gives us the ability to zoom in on each other's faces, as we have been doing, without actually repositioning the camera or having two cameras or anything like that. So a really useful thing to do with 4K footage is to put it on a lower resolution timeline. So that's what we're doing here. And we've split the timeline into 4 sections.
So section 1 is from the camera as is. Section 2, we add a color grade to it. Section 3, we add a second stream and overlay that with a transparency on top of the first stream. And section 4 is a mosaic blur.
That's it. So we just keep increasing the complexity in each section. And we're going to render the footage out as a QuickTime movie with H.264. And we're going to look at the overall render times, but we also need to look at these individual sections. So we got the stopwatch out to test those, and you're going to see why that's important as we go through the test.
So when it comes to working with this timeline, the M1 Max machines, the iMac and the workstation all played everything flawlessly. For the other machines, as the complexity increased, we started to see drop frames, but it's still usable.
It was actually, yeah. So let's put up the chart for the overall render times. So perhaps unsurprisingly, the slowest is the M1 Mini, which finished the render in 5 minutes and 40 seconds.
So when we did this test previously, some of you might remember it took over 7 minutes. So you may be wondering what's changed. Well, as Dave mentioned earlier, Resolve 17.3 introduced more optimization for M1.
Yeah, it's a nice improvement. And actually, we're seeing improvements across the board. It's not just M1, even the Intel machine is slightly quicker too, which is nice to see. So after the M1 Mini is the Intel MacBook Pro, which finished in 3 minutes and 59 seconds.
Yep, then we've got the Razer at 3 minutes 22 seconds. So does that surprise us?
Well, these two machines are actually very well matched, as we saw, for CPU and for RAM. And also, they've both got 4 gigabytes of video RAM, but the 1650 Ti has more raw compute performance than the 5300M in the MacBook Pro. And I suspect it's the smaller size of the Razer that may impact that performance, and that's why it's not a bigger margin of difference. But let's see how we go as we progress through the tests.
Yeah, absolutely. So next we have the M1 Pro models. The 8-core CPU with the 14-core GPU finished in 2 minutes and 9 seconds, and the 10-core CPU with the 16-core GPU finished in 2 minutes and 6 seconds. So should we be seeing more of a difference here?
I don't think so, because first of all, the 10-core has 2 additional CPU cores, but this isn't a CPU-bound process. And I think maybe it's not GPU bound either, and it might help just to understand how the render process is working here. So the 4K stream of B-RAW needs to be read and interpreted and decoded by the GPU. It's then encoded by the media engines that are on the M1 Pro. In fact, the M1 Pro has 1 media engine for H.264. So that's probably the limiting factor here. And since both M1 Pro chips have the same media engine, that's why we're seeing very similar performance. I suspect both of the GPUs are capable of feeding that encoding engine with enough of the B-RAW footage at enough speed so that there's no bottlenecking.
So it never breaks a sweat. But I know what some people are going to ask then, are we doing a fair test if some of these machines have encoders and some don't?
Well, all of the machines have encoders. Of course, Intel chips have something called QuickSync on board. NVIDIA's GPUs have encoders. And the MacBook Pro, the 16-inch Intel MacBook Pro, has the T2 chip.
Yes, it does.
Which does all sorts of things, but it does include an encoder as well. I don't think it's as powerful as the M1's encoder, but certainly there is one there. So all of the machines have some form of hardware optimization for encoding to H.264.
And also Resolve will pick the best encoder available for the job and make use of it.
That's been my experience so far, yeah.
Yeah. And remember, this is a real-world test, so it's appropriate that we use all the performance available to each machine to see how they cope with real-world scenarios.
Absolutely. This isn't a test between raw compute performance of specific GPUs. It's about the whole machine, all of its optimizations for this particular piece of software.
Yeah. That having been said, it was a slight surprise that the 24-core M1 Max finished 2 seconds ahead of my 32-core GPU M1 Max.
It was a surprise, actually, that I would say it didn't finish ahead. I would say that they're the same within a margin of error.
Okay.
But I think that the same thing is going on here as is going on with the M1 Pros. Now, remember, the M1 Pro has one media encoder, the M1 Max has two.
Okay.
So both of these M1 Max chips have the same number of encoders, and I think it's the same story. The GPU is perfectly capable of decoding the B-raw footage fast enough, so the limiting factor is the speed of the encoders. Hence, we get the same result.
Fair enough. And then, just to finish off the results, the workstation smokes them all, finishing in a mere 39 seconds.
Yeah. Wow. There we go. This, though, is where it's useful to look at the individual section times. So we've got separate charts for those. Let's just start with section 1. Now, remember, this is a single stream of B-raw coming straight off the camera. And we'll just put up all of the results together. What you can see is all of the machines are pretty quick here. But you might notice that the Razer and the Intel MacBook Pro have swapped positions, which is interesting.
Yeah, so section 2, that adds a color grade, remember. So for the M1 Mini, Razer and Intel MacBook Pro, that basically doubles the render time, suggesting they are working much closer to their limits. It had less effect on the other machines, though, which have more performance in reserve, and that is a key concept to bear in mind.
Yeah, absolutely. Now, section 3 adds that second stream of footage, and this really starts to hurt the slower machines, as we can see. We're seeing render times for these sections decrease by 2.5 to 3 times on all of the computers, apart from the workstation.
So why is that?
Well, that's because in the first 2 sections, the workstation is only using a single GPU, but of course it has 2 of those Quadro RTX GPUs in there. So when it gets to the second stream, it can start dividing the work, and the effect of the second GPU starts to come into the mix.
Okay, so a second GPU only benefits you if you have more than one stream?
Well, when it comes to final render in this situation, that's what I've seen in my testing. Yeah.
Okay.
There are other benefits to the second GPU, but of course that's irrelevant to the Apple Silicon Max. So what about section 4?
Well, of course, we're adding a blur effect there. And to be fair, that's a very lightweight effect, so we only see a marginal drop-off.
So hopefully you can see why we couldn't just post up the final render times for all of these things, because overall performance is going to depend upon how complex your timeline is, and this gets really interesting the more difficult that we get in our next test.
Which was what?
Well, we took 4 6K B-raw clips, which I downloaded off of Blackmagic's website. They're all shot at 24 frames per second. We're placing this 6K footage onto a 4K timeline. So we really are stepping up the complexity now. This is going to be a much tougher test for these machines. The clips are also anamorphic, so they're being de-squeezed. And again, we've got no proxies. There's no optimization in use here at all.
So we're dividing the timeline into sections. Section 1 is the 4 clips straight off the camera, one after the other. In section 2, we put 2 of the clips side by side. Section 3 adds a blur effect to one clip and a light effect to the other. In section 4, we have 3 clips simultaneously. Section 5 has effects applied. We used a skin smoothing filter on the 3rd clip, and section 6 is all 4 of those clips together. And finally, section 7 has the effects on all the clips. We're using a sharpen filter on the last.
Bear in mind that there are much more intensive effects than the ones that we're using in this test. For example, if you were trying to do some temporal noise reduction, that would be significantly more difficult than running a blur, for example.
Yeah, so you can't take this and say, oh, this machine will run this many streams with this many effects, because there's too many variables for that.
Exactly that, yeah. So let's just consider timeline playback. And this was okay, I think, for all of the single streams on all of the machines, but none of our machines were able to play the entire timeline without dropping frames. The weakest contenders in our mix, they start to drop frames as soon as there are 2 streams of that B-raw 6K. And the more powerful machines, the Workstation and the M1 Max machines, well, they could get a lot further into the timeline without dropping frames. But trying to render all of these streams and effects in real time and edit them, that's probably not a real world use case.
No.
It is just worth mentioning that you can switch on timeline optimizations within DaVinci Resolve for playback. And on a laptop screen, working with these kind of high resolution video sources, going down to half resolution or even quarter resolution, you're not going to be able to see the difference. The issue comes when you want to connect an external display, you want to get into the detail for color grading, or you need to do that final render. And that's why we've chosen to do this test without any of these optimizations switched on, so that we can show the raw horsepower of these machines. But it is fair to say that any of these machines with these optimizations on would be able to work with this footage.
So let's take a look at the render performance. We're rendering out to 4K resolution, again with H.264.
So as you can see here, we're not showing the razor, and that's because it didn't manage a time. It dropped to about half a frame per second whilst it was rendering section 5.
Yeah, it was really struggling. Do we think it overheated?
I don't think that was the issue here. I mean, we definitely saw some thermal throttling, but at this point in time, we got up Task Manager and we saw that the CPU was about 6% utilized. The GPU wasn't really utilized, but the video RAM was pinned, it was maxed out, and it was also using some shared system RAM as well. So I think it ran out of video memory.
I think that's a reasonable conclusion. It was the weakest point in the system, and all the physical evidence pointed to that as well.
So the last place of the finishers on our chart then is the M1 Mini, which managed to render in 4 minutes and 8 seconds.
Then it's the Intel MacBook Pro with 2 minutes 39 seconds. Now this interestingly also has 4 gigabytes of video RAM, but it managed the render.
And then we've got the M1 Pro machines, which again, they're very close to each other with 1 minute 35 and 1 minute 31 respectively.
Yeah, the iMac then puts in a very solid 1 minute 9 seconds.
That is quite impressive. Again, we find that the 24-core M1 Max finishes slightly quicker than the 32-core, but I'd say really they're the same within a margin of error, and that's 1 minute and 1 second.
The 6K footage is where the M1 Max is really starting to get close to the Workstation's performance, right?
Not quite. And I think here we really need to look at the individual sections to see what's happening. So let's start with section 1, which is the 4 clips straight off camera. We can see that the M1 Mini is really struggling with this section, and it's outperformed by the Intel MacBook Pro. The M1 Pro machines are slightly faster again, then it's the iMac and those M1 Max machines, which are actually faster than the Workstation for this section. And this is because certain video cards and frameworks handle certain scenarios better than others. And it just seems that the M1 Max and Pro chips, they're clearly better optimized for doing these single streams of B-roll.
In fact, even the iMac with its Vega 48 GPU did it faster. Quite a surprise.
Yes, it is. But things will be redressed in future sections. So let's start with section 2, where we've got 2 clips playing simultaneously. And as you can see from all the results, all of the machines really did quite a good job here.
Yeah, but section 3 is where it starts to get interesting. That's where we add the effects, and it slows the render performance for all the machines by a factor of 1.5 to 2.
Apart from the Workstation, which of course now takes advantage of its second GPU here and doesn't slow down at all.
But section 4, 3 clips simultaneously and all the machines, well, they're still in the game.
Yeah,
apart from the poor old Razor.
Well, we excluded the Razor.
I know, but I feel like it's sad.
Section 5, this is where we added the effects, and again, noticeable slowdown apart from the Workstation.
Section 6, that's the 4 clips simultaneously, and again, all the machines are still in the same order.
And section 7, finally, this is a really tough bit. We're adding the effects to all of these 4 streams, and you can see some big slowdowns now. The M1 Mini, the Intel MacBook Pro, and the M1 Pro machines are all less than half the speed that they managed for the previous section.
The M1 Max is about half the speed, but the iMac fares slightly better, and the Workstation is still flying through it.
So again, when we look at the total render time performance for these tests, it doesn't truly represent the results. So whereas you thought the M1 Max was drawing quite close to the Workstation, in truth, if it was a more complicated timeline, there wouldn't be so much of a contest. But some people don't have more complicated timelines, they have simpler timelines. And in that case, we're starting to see where the optimization of the M1 really
can pay dividends, and it can perform against machines that cost significantly more money, let's face it.
Yeah, it's important to remember these M1 Max machines are notebooks, and they're delivering performance that is edging out a highly spec'd iMac, which is why it's so important not to just look at the GPU benchmarks in isolation.
Absolutely, yeah. It is really amazing, this level of optimization that these machines have for video work. Even when it's working with a codec like BRAW, so this isn't being decoded by those optimizations within the M1 chip. This is using GPU horsepower. It's phenomenal for a notebook computer to be able to achieve this.
Yeah, and apparently it gets even better when you're working in ProRes, in Final Cut Pro.
Yeah, I'm looking forward to testing that, and we will test that on the channel in due course. But for now, let's up the ante again. We're going to look at a timeline here with 12K B-raw footage, and again, this has been shot at 24 frames per second. I downloaded these sample clips off of Blackmagic's website, and I did feature these in a previous video if they look familiar. We're going to put the 12K footage onto a 4K timeline, and we're doing that really to make it a reasonable test for these machines. I think if you're shooting 12K, you'd probably be more likely to choose an 8K timeline.
Yeah.
But we're going to put 12K on a 4K timeline for this. Again, there's no proxies, there's no optimizations at all.
Again, we've divided this into sections, but we've just done 3 this time, haven't we? So section 1 is 2 short clips straight from the camera. Section 2 is a clip which has a LUT and a basic colour grade applied. Section 3 also has the LUT and grade, but it's been stabilised, and we're also doing some auto reframing, and there's also a keyframed zoom.
Now, all of the machines can play back this 12K footage just fine. Why is that, Pete?
Because we're not loading every pixel into the frame, just those that we need.
And so for each frame of this 12K footage is 79 million pixels. But of course, on a 4K timeline, we don't need to load in all of those 79 million pixels. So the system must be skipping pixels when it loads in the footage. When it comes to rendering, though, the GPU is going to need to decode all of those pixels. That is going to be tough. And it's really going to test machines that don't have much in the way of video RAM. I'm looking at you, Razer and Intel MacBook Pro.
My hope isn't high. So let's render out to 4K DCI, again with H.264, and let's see the final render times.
Now, we've not included the Razer because we know it can't do it. I've already tested this in the previous video. So last place is actually going to the Intel MacBook Pro, which struggled along and finally wheezed to a finish after 15 minutes and 5 seconds.
And that's where the 4 gigabytes of video RAM is starting to show. It's the same issue that affected the Razer is now hitting the MacBook.
Yeah, and if you remember when this happened, Pete, your MacBook, which had been blowing its fans like fury, suddenly got quiet. So I think exactly the same thing happened to the Razer. Minimal CPU and GPU usage, just bottlenecked by the video RAM at that point.
Yeah, so the GPU and the CPU weren't being taxed because they weren't being given stuff quickly enough to deal with it.
Yeah, that's my assessment, and I'm sure there'll be people in the comments who disagree with me, but it seems interesting that this happened to both machines that were limited by 4 gigabytes of video RAM, but it doesn't happen to the M1 Mini, which, as you can see here, finished this render in 2 minutes 57 seconds. Now, the 8-core GPU that's in the M1 Mini is almost as powerful as the 5300M that's in the Intel MacBook Pro. Of course, the difference is that the M1 Mini has unified memory. So the GPU in the M1 can access all of the 16 gigabytes of system RAM. So it doesn't have that limitation like the MacBook Pro.
Not to mention it's got a better encoder.
So, of course, whilst in the previous charts we saw that 6-core MacBook Pro outperforming the M1 Mini, once we get to a workload that needs more video RAM, the M1 is able to keep on going. And I think, Pete, that's an interesting insight because it's relevant to all of the M1 Macs that we're looking at today.
Yeah, I'd say it's a key advantage of the Apple Silicon architecture. So the M1 Pro machines, they came in at 1 minute 43 and 1 minute 42. Again, no real difference in performance, and that's because they have the same amount of unified memory for the B-raw decode work and the same encoders for the H.264 final output.
And the iMac proves that it's still worthy in the Apple Silicon era. It finished in 1 minute and 2 seconds. The M1 Max machines, though, finished in 50 and 49 seconds, respectively, because I think maybe this workload is just not sufficient to allow the difference in RAM to make any impact on the outcome. It seems like 32 gigabytes is indeed enough, Pete.
It does sound like it might be. And the workstation finishes in 25 seconds.
No surprises, really. But the individual sections will show where things got difficult. So let's take a look at the chart for section 1.
So this was the 2 short clips straight off the camera. And the M1 Pro did this section in 2/3 of the time the M1 Mini took. But notice the Max machines are twice as quick again. This seems like a pretty clear comparison of the Media Engines.
It does look like that, doesn't it? Yeah. Okay, section 2 then. Let's have a look at the chart for this. This is where we added a graded clip of the very beautiful lady. More challenging for all of these machines, and they all slow down. Though you'll notice the iMac slows by a smaller margin compared to the M1 Max, and the workstation is barely any different at all.
Yeah, it's barely any different. But section 3, that's more difficult again. And I think it's fair to say the M1 Mini is probably out of its depth at this point.
Looks like it.
The Intel MacBook Pro is severely bottlenecked and just can't use its raw performance, again, for the reasons we've discussed. The other machines, they all slow down, but it's fair to say they're doing fine.
So what do we learn from all of this testing? I think we need to maybe just put the caveats out there again, that you can't really judge the performance of these machines by looking at the numbers of this test in isolation. And we're not basing our final judgment on these machines on purely this test. We're using this test plus all of the other testing that we've done to come to our conclusions.
Yeah. I think if you are serious about video editing on the go, though, we can say that the M1 Max machines represent tremendous value and performance per pound or dollar. And if you're working with Resolve B-Raw, then you probably don't need more than a 24-core GPU and 32 gigs of RAM.
Which spec did you go for, Pete?
Something similar to that.
I thought it was. What about the M1 Pro? I think this is fine for video editing. I think, you can do video editing on the standard M1, so of course you can do video editing on the M1 Pro, and you've seen from the results that we've given you that it can do a job. But it does lack the additional media engines of the M1 Max. It lacks that additional memory bandwidth. It's down on GPU cores. So I think if you're a professional working in video editing, you'd probably see a return for the additional investment going from M1 Pro to M1 Max.
Yeah, I would say that's reasonable. When it comes to x86 laptops, be that PC or Mac, I think it's fair to say they just don't have the same optimizations as the new Apple Silicon. It's also fair to say we saw a lot of bottling because of video RAM on the machines we had. There are other PC laptops out there with much more powerful video cards, much more powerful GPUs, more video RAM, and I suspect they would do much better in this test. I'd love to see that if we can get our hands on some.
So if there are any PC manufacturers out there that want to send us some high-spec PC notebooks for testing, we'd be very happy to oblige.
We would.
And when it comes to getting the maximum amount of performance for very complex video workloads, and do bear in mind that not everybody needs the maximum amount of performance and not everybody has really complex video workloads. But if that is you, then x86 workstations, whether that's a PC or a Mac Pro, is still the definitive choice for that type of work. Of course, there's then the question of power efficiency, and everybody knows that the Apple Silicon Macs are offering the maximum performance per watt, and x86 is just not competing at the moment with that, and probably never will be able to. And that really is quite interesting for the future. Think about a new Mac Pro machine, Pete, with 2 M1 Max chips in it, or even 4 M1 Max chips in it. Now, of course, that is going to consume quite a lot more power than one of these notebooks, but it still won't be anywhere near the consumption of that Lenovo.
I think it will also consume my wallet quite quickly. You've got to ask, it's a salivating prospect, but at what price?
Well, that is the million-dollar question.
So when we started doing video testing for Apple Silicon a year ago now with the M1s, we were asking the question, what was the best Mac that you could buy for video editing at the time? And the conclusion we came to was the iMac.
Yeah, because of the amount of performance you get for the price. And I think it's really nice to see that it's still holding its own in this competition.
Definitely agree with that. I also think it's fair to say that the tests that we've done over the last day or so have helped us, and the tests you've done last week, to really start building up a picture of this new batch of Apple Silicon, seeing what it can do. And we're really starting to understand where these machines sit now and who they're best used for. In fact, we did a bit of a buying guide on the podcast this week, didn't we?
We did, yeah. So if you haven't watched our podcast before, it's a similar setup with Pete and I talking about things, and we'll put a link in the description to that episode. I'm particularly excited to read all of your comments this time. I mean, some of you guys, you've got such insightful thoughts about Apple Silicon and all of these things. So look forward to hearing from you and all of the things that we've missed in our testing. Please consider subscribing to the channel if you haven't done so already.
Better do that.
So thanks in advance for all of your likes, even your dislikes, for your comments, of course, and for sharing this content with others who you think might find it interesting. And we'll see you again soon for some more geekery.